Hello students, welcome to mathematics class. Students, this is part 10 of the chapter Algebraic Expressions and Identities. In this part 10, we will learn about algebraic identities. And now coming to the important question, what is an identity? Now to know about what is an identity, let us consider two equalities, that is 5x minus 2 and 5x minus 2 equal to 2x plus 1 and 2 of 3x plus 1 equal to 6x plus 2. Now, we will call both of them as equations. Why we call them as equations? Because they are equalities having a variable. Now, both equations will go for verifying for the value of x equal to 1. Now, coming to the equation 1, I will verify it for x equal to 1. You know what is verification? Verification is just nothing but we will substitute x equal to 1 on LHS of this equality, that is 5x minus 2 is LHS. On substitution, instead of x 1, it becomes 5 of 1 minus 2, where in this step 1 we got 5 of minus 1. In step 2, I will get 5 into 1 is 5 minus 2, and in step 3, I will get the value as 3. Now, I will go for substituting x equal to 1 on right hand side, that is 2x plus 1. In step 1, instead of x I will substitute 1, so 2 of 1 plus 1 I will get in step 1, and in step 2, 2 into 1 becomes 2, 2 plus 1, and in step 3 I got value of RHS as 3. Now, you know, in the value of LHS I got 3, and in the value of RHS also, that is the value of RHS is also 3. Therefore, I say LHS value is equals to RHS value on substitution of x equals to 1, that means for x equal to 1. Therefore, I say x equals to 1 is satisfying this equation. Now, let us take further, we will go for now verifying equation 2 for the value of x equal to 1. Same way, we will go for substituting x equals to 1 on left hand side, that is here left hand side is 2 of 3x plus 1, where in step 1 2 of 3 into, that is instead of x I am substituting 1, 3 of 1 plus 1. So, 2 into 3 into 1 is 3, 3 plus 1, it is nothing but 2 into 4, and 2 into 4 is 8. So, in step 2, step 3 and step 4, I got at the end the value of LHS as 8. Now, similarly, I will go for substituting x equals to 1 on RHS or in RHS, I mean. Here RHS is 6x plus 2. If I substitute in step 1, 6 times of 1 plus 2, instead of x I substituted as 1. So, 6 ones are 6 plus 2 and 8. In step 3, I got the value of RHS as 8. Now, I can say LHS value is also 8 and RHS value is also 8. Therefore, the value of LHS is equals to RHS for x equal to 1 even in the equation 2 also. Now, we will go further little more. We will take these two equations. Now, we will verify both of them for different value such as x equal to 2. Now, if I consider x equal to 2 in the equation 1 I have taken and I am substituting instead of x equals to 2 and verifying the equation 1. Now, substitute x equals to 2 in LHS of the equation 1, that is 5x minus 2, and in step 1 of this LHS 5 of 2 minus 2, and in step 2 5 into 2 is 10, 10 minus 2, and in step 3 I got the value of LHS as 8, whereas I will substitute x equals to 2 even in RHS of the equation 1, that is 2x plus 1. In that, if I substitute instead of x as 2, it becomes 2 times of 2 or 2 of 2 plus 1, that is step 1. In step 2, it becomes 2 2s are 4, 4 plus 1, and in step 3, 4 plus 1 is 5. Here you could see the value of RHS not being 8 and it is being 5. So, can I say now LHS value equals to RHS value? No. Here LHS value is not equal to RHS value for x equal to 2. So, you could make out that for x equals to 2, equation 1 is not getting true, and when I verify that, I could find left hand side value for x equals to 2 is different from the right hand side value for x equals to 2. Now, let us go for the same verification of equation 2, but for x equal to 2. Now, children, same procedure I will adopt. I will substitute x equals to 2 in the left hand side of equation 2, that is 2 into 3x plus 1 in that left hand side. I will substitute instead of x 2, that means 2 times of 3 multiplied by 2 plus 1. You know that is step 1. In step 2, I will get 2 into 3 into 2 is 6, 6 plus 1 comes inside the bracket, and 2 into 6 plus 1 is 7, that comes as a step 3, and in step 4 I will get the value finally 2 7s are 14 being the value of LHS. Now, children, I will find out by substituting x equal to 2 in the right hand side of equation 2, that is equation 2 right hand side is 6x plus 2, and I will substitute instead of x 2, it becomes 6 of 2 plus 2, that is 6 into 2 plus 2 as a step 1. In step 2, I will get 6 2s are 12 plus 2, and in step 3, I got 12 plus 2 14. Children, here right hand side value is equals to 4, even left hand side value is also 14, left hand side value is also 14. Therefore, left hand side value equals to right hand side value, that is LHS equals to RHS, even in the equation 2 for x equals to 2. You can substitute different values for x in both the equations, and you can see that only equation 2 getting true, that is being left hand side value equals to right hand side value for any value of x. But whereas in the equation 1 we will never get other than x equals to 1 satisfying the equation 1. Now children, here in the equality 5x minus 2 equals to 2x plus 1, we have only x equals to 1, making it left hand side equals to right hand side. Whereas in the equality 2 times of 3x plus 1 equals to 6x plus 2, any value of x makes LHS equals to RHS. Now what is the difference between these two equalities? Let us see. See children, we found that for any value of x is LHS equals to RHS in the equality 2 or in equation 2. Such equality, true for every value of the variable in it, is called an identity. This is called identity, and it is algebraic identity. Whereas for only one value of a variable, if any equality is true, then it is called, this 5x minus 2 equals to 2x plus 1 will be called as an equation. So, an equation is true only for certain values, and it is not true for all the values of the variable. Therefore, this is an example for equation only. It is algebraic equation. Okay. So, you need to know, very important, the difference between algebraic equation and algebraic identity. You know, in this algebraic equation 5x minus 2 equals to 2x plus 1, only for x equals to 1 it is true, that is the left hand side equals to right hand side, whereas it is not true for x equals to 2. Even you can check, it is not true for 0, x equals to 0 also. 5 of 0 becomes 0, 0 minus 2 is minus 2, and this becomes 2 of 0 plus 1, where it is 1, minus 2 is not equals to plus 1. So, you can verify that. Children, now let us come to the algebraic identity. Is such an equality which is true for every value of the variable in it. Algebraic equation is an equality which is true for only certain values of the variable in it, and it is not true for all the values of the variable. Okay. So, you can take this as definitions of algebraic identity and algebraic equation. Now, we shall go for another important topic called standard identities. Now, let us see what are the standard identities. Students, we shall now study 3 identities which are very useful in our further work. These identities are obtained by multiplying a binomial by another binomial. You know how to multiply a binomial by another binomial. Now, let us first consider the product of a plus b into a plus b or a plus b whole square. See students, a plus b multiplied by a plus b, here we have a binomial multiplied by a binomial only. So, a plus b into a plus b if you want to do, that is a plus b whole square if you want to do, we take a into a plus b plus b into a plus b. Now, each term of one binomial multiplies with the each term of the other binomial. That is, you know, a into a gives a square plus a into b gives ab plus b into a gives ba plus b into b gives b square. You know, AB and BA are equal by commutative property. Therefore, AB plus AB is 2 times AB. Thus, we got a plus b whole square equals to a square plus 2ab plus b square being one of the important standard identity, and this is first standard identity. Now, we shall go for another product of a binomial by binomial. Now, I am taking a minus b multiplied by a minus b, that means it is also called a minus b whole square. A number multiplied by itself for twice is square of that. So, with that we say a minus b whole square is equals to a minus b into a minus b. I will multiply a into a minus b and minus b into whole of a minus b, that is each term of one binomial multiplies with each and every term of the other binomial, that is a into a gives me a square, a into minus b gives minus b minus ab, minus b into a minus ba, minus b into minus b, minus into minus plus b into b, b square. You know, AB equals to BA, therefore, this BA can be considered as AB, AB and AB. So, two negatives, so minus AB and minus AB becomes minus 2AB, like minus 1 is minus 2. Now, thus we got another important algebraic identity called a minus b whole square is a square minus 2ab plus b square. This is second algebraic identity. Now, we will go for finally third product with the a plus b multiplied by a minus b. So, a plus b into a minus b. Similarly, algebraic identities, how first and second we found by multiplying, we will multiply first a into whole of a minus b plus b into whole of a minus b. So, that gives a into a square minus a into b minus ab. So, a into minus b becomes minus ab plus b into a plus ba plus b into minus b plus into minus minus b into b, b square. So, we get a square minus ab plus ba minus b square. Since ab equals to ba, we have this also being ab, minus ab plus 1 minus 1 becomes just like cancellation. Now, we get a square minus b square. Thus, this is third important standard algebraic identity. A plus b into a minus b is a square minus b square. So, this 1, 2, 3, these three are known as standard identities in algebraic identities for your class 8th level. Students, now we will go for one of the try these. So, here put minus b in the place of b in identity 1. You know, identity 1 is a plus b whole square is a square plus 2ab plus b square. He is asking us to place minus b in the place of b. That means, I will take in the place of b minus b and I will go for writing identity. Now, a square plus 2 times of a, instead of b I will get minus b, plus instead of b I will get minus b whole square. Now, here plus into minus, it becomes a minus b whole square equals to a square plus 2 into a plus 2a plus 2a into minus b is minus 2ab. And what is minus b whole square? See children, minus b whole square nothing but minus b into minus b. So, minus b whole square gives you minus b into minus into minus is plus, b into b is b square. So, I will substitute instead of minus b whole square this plus b square. So, is this is second identity or not? Yes, this is second identity only. We got second identity only. So, here for this answer is yes. We had placed instead of b minus b in the identity number 1 and we verified whether we get second identity or not. Then coming to the another important third useful identity. What is third useful identity? It is x plus a into x plus b. Again we have got binomial x plus a multiplied with the another binomial x plus b. So, you know how to multiply x plus a into x plus b. Binomial x plus a's each and every term multiplies with each and every term of the other binomial x plus b. Now, we got x of x plus b plus a of x plus b, that is x into x x square, x into b x b, a into x a x plus a into b a b. Now, children, are there any like terms here? Yes, it is bx and ax are like terms. Now, I will take out that common. So, x square plus, when I take x common out, it becomes x of a plus b. A plus b gives you one together some number plus a into b. Here I am sorry, it is supposed not to be there. It is only just a plus b. Let me correct it. So, here students, we got a b only as it is, it comes, and only the like terms x b and a x, where x is taken out common, it becomes a plus b. So, this gives you another fourth identity, and let us go to try this on this. Verify identity for, that is x plus a into x plus b equals to x square plus a plus b into x plus a into b by substituting x as 5, a as 2, b as 3. So, I will take left hand side separately, that is x plus a into x plus b, and I will take right hand separately. Left hand side x is 5 plus a is 2, 5 plus 2 into 5 plus b is 3 plus 3. So 5 plus 2 is 7, 7 into 5 plus 3 is 8, so 7 8s are 56. And now right hand side I am taking x square plus a plus b into x plus ab, where x square is nothing but 5 square plus a plus b nothing but 2 plus 3 into 5 plus 2 into 3. Now 5 square is 25 plus 2 plus 3 is 5, 5 into 5 plus 2 3s are 6, it becomes now 25 plus 5 5s are 25 plus 6, it becomes 56. Now I say therefore left hand side value equals to right hand side value, where a is substituted as 2, b is substituted as 3 and x is substituted as 5. Now children, this second, third and fourth. Now in this second, third and fourth, the special case of identity 4 with a equals to b. That means when I have x plus a into x plus a only, it becomes x plus a whole square. It is just like first identity a plus b whole square. It is supposed to be x square plus a plus a into x plus a square. That means x square a plus a is 2a, 2ax plus a square. It gives one sort of a first identity type only. Now third and fourth you do on your own, that I am giving as homework. I can say at the end, this fourth identity is the general form of all the three standard identities. It is a generalization of all the three identities. You will realize once you do third and fourth also. So with this I will wind up this session. So next class I will be teaching you geometrical interpretation of these standard identities in a practical manner. So I expect you all in our next class having graph sheets, ruler, scissors along with you. We will do practically the work, and that you will be verifying this geometrically how algebraic identities will be. So till then, take care of yourself. Jai Hind. Thank you.